Sulfur dioxide is the chemical compound with the formula SO2. At standard atmosphere, it is a toxic gas with a pungent, irritating, and rotten smell. The triple point is 197.69 K and 1.67 kilopascals. It is released naturally by volcanic activity. Sulfur dioxide was used by the Romans in winemaking, when they discovered that burning sulfur candles inside empty wine vessels kept them fresh and free from vinegar smell. Structure and bonding: SO2 is a bent molecule with C2V symmetry point group. A valence bond theory approach which just considered s and p orbitals would describe the bonding in terms of resonance between two resonance structures. The sulfur-oxygen bond has a bond order of 1.5. There is support for this simple approach that does not invoke d orbital participation. In terms of electron counting formalism, the sulfur atom has an oxidation state of +4 and a formal charge of +1. Occurrence: it is found on Earth and exists in very small concentrations and in the atmosphere at about 1 ppb. On other planets, it can be found in various concentrations, the most significant being the atmosphere of Venus, where it is the third most significant atmospheric gas at 150 ppm. There, it condenses to form clouds, and is a key component of chemical reactions in the planet's atmosphere and contributes to global warming. It has been implicated as a key agent in the warming of early Mars, with estimates of concentrations in the lower atmosphere as high as 100 ppm, though it only exists in trace amounts. On both Venus and Mars, its primary source, like on Earth, is believed to be volcanic. It is also believed to exist in trace amounts in the atmospheres of Jupiter and Jupiter. As an ice, it is thought to exist in abundance on the Galilean moons, a sublimating ice or frost on the trailing hemisphere of Io, a natural satellite of Jupiter, and in the crust and mantle of Europa, Ganymede, and Callisto, possibly also in liquid form and readily reacting with water. Production: sulfur dioxide is primarily produced for sulfuric acid manufacture. In the United States in 1979, 23.6 million tons of sulfur dioxide were used in this way, compared with 150,000 tons used for other purposes. Most sulfur dioxide is produced by the combustion of elemental sulfur. Some sulfur dioxide is also produced by roasting pyrite and other sulfide ores in air. Combustion routes: sulfur dioxide is the product of the burning of sulfur or of burning materials that contain sulfur, S plus O2 or SO2. IH equals -297 kJ per mole. To aid combustion, liquefied sulfur is sprayed through an atomizing nozzle to generate fine drops of sulfur with a large surface area. The reaction is exothermic, and the combustion produces temperatures of 1000 to 1600 degrees Celsius. The significant amount of heat produced is recovered by steam generation that can subsequently be converted to electricity. The combustion of hydrogen sulfide and organosulfur compounds proceeds similarly. For example, 2H2S plus 3O2 or 2 hours duo plus 2SO2. The roasting of sulfide ores such as pyrite, sphalerite, and cinnabar also releases SO2, 4Fe2 plus 11O2 or 2Fe2O3 plus 8SO2, 2ZNS plus 3O2 or 2ZNO plus 2SO2, HGS plus O2 or Hg plus SO2. 4Fe plus 7O2 or 2Fe2O3 plus 4SO2. A combination of these reactions is responsible for the largest source of sulfur dioxide, volcanic eruptions. These events can release millions of tons of SO2. Reduction of higher oxides: sulfur dioxide can also be a byproduct in the manufacture of calcium silicate cement. Car-SO4 is heated with coke and sand. In this process, 2 Car-SO4 plus 2 CO2 plus Ca2 CaSO3 plus 2 SO2 plus CO2. Until the 1970s, commercial quantities of sulfuric acid and cement were produced by this process in Whitehaven, England. Upon being mixed with shell or marl, and roasted, the sulfate liberated sulfur dioxide gas, used in sulfuric acid production. The reaction also produced calcium silicate, a precursor in cement production. On a laboratory scale, the action of hot sulfuric acid on copper turnings produces sulfur dioxide. Cu plus 2 hours 2 SO4 a Cu SO4 plus SO2 plus 2 hours 2O, from sulfate. Sulfate results from the reaction of aqueous base and sulfur dioxide. The reverse reaction involves acidification of sodium metabisulfate, H2SO4 plus Na2S2O5 a 2SO2 plus Na2SO4 plus H2O, reactions, industrial reactions, treatment of basic solutions with sulfur dioxide affords sulfate salts, SO2 plus 2 NaO and Na2SO3 plus H2O, featuring sulfur in the plus 4 oxidation state. Sulfur dioxide is a reducing agent. It is oxidized by halogens to give the sulfuryl halides, such as sulfuryl chloride, SO2 plus Cl2 or SO2Cl2. Sulfur dioxide is the oxidizing agent in the Claus process, which is conducted on a large scale in oil refineries. Here, sulfur dioxide is reduced by hydrogen sulfide to give elemental sulfur, SO2 plus 2 hours 2SA3S plus 2 hours 2O. The sequential oxidation of sulfur dioxide followed by its hydration is used in the production of sulfuric acid. 2SO2 plus 2 hours 2O plus O2 are 2 hours 2SO4. Laboratory reactions. Sulfur dioxide is one of the few common acidic yet reducing gases. It turns moist litmus pink, then white. It may be identified by bubbling it through a dichromate solution, turning the solution from orange to green. It can also reduce ferric ions to ferrous. Sulfur dioxide can react with certain 1,3-dienes in a cheltropic cycloaddition reaction to give organosulfur compounds. Sulfur dioxide can bind to metal ions as a ligand to form metal sulfur dioxide complexes, typically where the transition metal is in oxidation state 0 or +1. Many different bonding modes are recognized, but in most cases, the ligand is monodentate, attached to the metal through sulfur, which can be either planar and pyramidal I1. Uses: precursor to sulfuric acid. Sulfur dioxide is an intermediate in the production of sulfuric acid, being converted to sulfur trioxide, and then to oleum, which is made into sulfuric acid. Sulfur dioxide for this purpose is made when sulfur combines with oxygen. The method of converting sulfur dioxide to sulfuric acid is called the contact process. Several billion kilograms are produced annually for this purpose. As a preservative, sulfur dioxide is sometimes used as a preservative for dried apricots, dried figs, and other dried fruits, owing to its antimicrobial properties, and is called E220. When used in this way in Europe. As a preservative, it maintains the colorful appearance of the fruit and prevents rotting. It is also added to sulfured molasses. In winemaking, sulfur dioxide was used by the Romans in winemaking, when they discovered that burning sulfur candles inside empty wine vessels keeps them fresh and free from vinegar smell. Sulfur dioxide is still an important compound in winemaking, and is measured in parts per million in wine. It is present even in so-called unsulfurated wine at concentrations of up to 10 mg per liter. It serves as an antibiotic and antioxidant, protecting wine from spoilage by bacteria and oxidation. Its antimicrobial action also helps to minimize volatile acidity. Sulfur dioxide is responsible for the words contains sulfites found on wine labels. Sulfur dioxide exists in wine in free and bound forms, and the combinations are referred to as total SO2. Binding, for instance to the carbonyl group of acetaldehyde, varies with the wine in question. The free form exists in equilibrium between molecular SO2 and bisulfite ion, which is in turn in equilibrium with sulfate ion. These equilibria depend on the pH of the wine. Lower pH shifts the equilibrium towards molecular SO2, which is the active form, while at higher pH more SO2 is found in the inactive sulfate and bisulfite forms. The molecular SO2 is active as an antimicrobial and antioxidant, and this is also the form which may be perceived as a pungent odor at high levels. Wines with total SO2 concentrations below 10 ppm do not require contains sulfites on the label by US and EU laws. The upper limit of total SO2 allowed in wine in the US is 350 ppm. In the EU it is 160 ppm for red wines and 210 ppm for white and rosé copyright wines. In low concentrations, SO2 is mostly undetectable in wine, But at free SO2 concentrations over 50 ppm, SO2 becomes evident in the nose and taste of wine. SO2 is also a very important compound in winery sanitation. Wineries and equipment must be kept clean, and because bleach cannot be used in a winery due to the risk of cork taint, a mixture of SO2, water, and citric acid is commonly used to clean and sanitize equipment. Compounds of ozone are now used extensively as cleaning products in wineries due to their efficiency, and because these compounds do not affect the wine or equipment. As a reducing agent, sulfur dioxide is also a good reductant. In the presence of water, sulfur dioxide is able to decolorize substances. Specifically, it is a useful reducing bleach for papers and delicate materials such as clothes. This bleaching effect normally does not last very long. Oxygen in the atmosphere reoxidizes the reduced dyes, restoring the color. In municipal wastewater treatment, sulfur dioxide is used to treat chlorinated wastewater prior to release. Sulfur dioxide reduces free and combined chlorine to chloride. Sulfur dioxide is fairly soluble in water, and by both IR and Raman spectroscopy. The hypothetical sulfurous acid, H2SO3, is not present to any extent. However, such solutions do show spectra of the hydrogen sulfate ion, HSO3, by reaction with water, and it is in fact the actual reducing agent present, SO2 plus H2OAA HSO3 plus H+, biochemical and biomedical roles. Sulfur dioxide is toxic in large amounts. It or its conjugate base bisulfite is produced biologically as an intermediate in both sulfate-reducing organisms and in sulfur-oxidizing bacteria, as well. The role of sulfur dioxide in mammalian biology is not yet well understood. Sulfur dioxide blocks nerve signals from the pulmonary stretch receptors and abolishes the Heringer-Urobreyer inflation reflex. As a refrigerant, being easily condensed and possessing a high heat of evaporation, sulfur dioxide is a candidate material for refrigerants. Prior to the development of chlorofluorocarbons, sulfur dioxide was used as a refrigerant in home refrigerators. As a reagent and solvent in the laboratory, sulfur dioxide is a versatile inert solvent widely used for dissolving highly oxidizing salts. It is also used occasionally as a source of the sulfonyl group in organic synthesis. Treatment of aryl diazonium salts with sulfur dioxide and cuprous chloride yields the corresponding aryl sulfonyl chloride, for example. As an air pollutant, sulfur dioxide is a noticeable component in the atmosphere, especially following volcanic eruptions. According to the United States Environmental Protection Agency, the amount of sulfur dioxide released in the U.S. per year was. Sulfur dioxide is a major air pollutant and has significant impacts upon human health. In addition, the concentration of sulfur dioxide in the atmosphere can influence the habitat suitability for plant communities, as well as animal life. Sulfur dioxide emissions are a precursor to acid rain and atmospheric particulates. Due largely to the U.S. EPA unregistered trademark acid rain program, the U.S. has had a 33% decrease in emissions between 1983 and 2002. This improvement resulted in part from flue gas desulfurization, a technology that enables SO2 to be chemically bound in power plants burning sulfur-containing coal or oil. In particular, calcium oxide reacts with sulfur dioxide to form calcium sulfate, Ca+ plus SO2 or CaSO3. Aerobic oxidation of the CaSO3 gives CaSO4, anhydrite. Most gypsum sold in Europe comes from flue gas desulfurization. Sulfur can be removed from coal during the burning process by using limestone as a bed material in fluidized bed combustion. Sulfur can also be removed from fuels prior to burning the fuel, preventing the formation of SO2 because no sulfur remains in the fuel from which SO2 can be formed. The Claus process is used in refineries to produce sulfur as a byproduct. The Sulfur process has also been used to remove sulfur from fuel. Redox processes using iron oxides can also be used, for example, low-cat or sulfurics. Fuel additives, such as calcium additives and magnesium oxide, are used in gasoline and diesel engines to lower the emission of sulfur dioxide gases into the atmosphere. As of 2006, China was the world's largest sulfur dioxide polluter, with 2005 emissions estimated to be 25,490,000 short tons. This amount represents a 27% increase since 2000, and is roughly comparable with U.S. emissions in 1980. Safety. Inhalation. Inhaling sulfur dioxide is associated with increased respiratory symptoms and disease, difficulty in breathing, and premature death. In 2008, the American Conference of Governmental Industrial Hygienists reduced the short-term exposure limit to 5 parts per million. The OSHAPEL is currently set at 5 ppm time-weighted average. NIOSH has set the IDLH at 100 ppm. In 2010, the EPA revised the primary SO2 and AAQS by establishing a new 1-hour standard at a level of 75 parts per billion. EPA revoked the 2 existing primary standards because they would not provide additional public health protection given a 1-hour standard at 75 ppb. A 2011 systematic review concluded that exposure to sulfur dioxide is associated with preterm birth. Ingestion. In the United States, the Center for Science in the Public Interest lists the 2 food preservatives, sulfur dioxide and sodium bisulfite, as being safe for human consumption except for certain asthmatic individuals who may be sensitive to them, especially in large amounts. Symptoms of sensitivity to sulfating agents, including sulfur dioxide, manifest as potentially life-threatening trouble breathing within minutes of ingestion. See also, sulfur trioxide, sulfur iodine cycle, National Ambient Air Quality Standards, references. External links, United States Environmental Protection Agency sulfur dioxide page, International Chemical Safety Card 0074, IARC monographs. Sulfur dioxide and some sulfites, bisulfites and metabisulfites V54. 1992. p. 131. NIOSH Pocket Guide to Chemical Hazards, CDC Sulfur dioxide NIOSH Workplace Safety and Health Topic, Sulfur dioxide, Molecule of the Month.